Hello, everyone. It's good to be back in Serbia. I was here a couple of years ago. Belgrade, though. Enjoyed it very much. The topic that brings me here today is slightly different. I hope you will enjoy it. You already heard from my good friend Jovan this morning. He's a local. I still have to go through a little bit of context about Zalando, what it does. I also just realized that I'm the man with many different roles. I was software engineering on the previous screen. Now I'm a site reliability engineer on this one. Sometimes I'm also an engineering lead. Sometimes I'm a principal engineer. It doesn't really matter. Zalando, it's probably not known, so well known for a lot of you. Zalando is Europe's leading online fashion platform. Basically, we are in the e-commerce space selling fashion. We sell clothes, we sell shoes, a bunch of those things. It's a very complex platform. The relevant part is the size, the context. Zalando is operating in 17 European markets, and last year the revenue was over 5.4 billion. Where we are distributed, sadly, we don't have an office in Serbia. I know that this could be interesting for a lot of you, but we don't have one yet. Our tech headquarters is in Berlin. We have a couple of tech hubs across Europe, in Helsinki, in Lisbon, Dublin, and Dortmund, and then a couple of other tech offices in Germany. This is the whole dimension of the organization, but the tech department where I work, where Jovan works, this is where we do a lot of interesting stuff. Some of those things were the trigger for this talk today. We have around 2,000 employees in the tech department alone. A lot of those are engineers like myself. And when I joined 6 years ago, we were 150 engineers. No, 150 in the whole tech department, and now we are 2,000. And all of that growth comes with certain pains in between. Some of those pains, which I guess you all agree and probably experience, is that with growth, certain things don't scale that well, and things go wrong every now and then. Which is a good thing, because usually you want to be monitored, you want to be alerted when things go bad. And how we do those things is not always the best way, at least in my opinion and the industry's opinion. And that's what I'm going to talk about. I'm going to talk about monitoring, alerting, and eventually a little bit about service level objectives, which was already mentioned today. A quick show of hands. Assume this is your typical monitoring tool that you have in a wallboard close to your team area, and the red one usually means something is bad. Quick show of hands if you experience something like this, that something is red, and you just leave it like that, and it stays day after day after day. The other ones are lying. I think everyone goes through this. At least if you are actually actively doing the monitoring, it always ends up happening. I call this driven by red monitoring. My experience has shown me one thing that is very important. When you started working on your monitoring, you didn't plan for this. You planned to monitor the right things, to act before things happen, and be on top of your game. But life happens. You didn't plan for this. No one likes it. Whoever has to deal with this day after day hates it. Your next colleague that just was onboarded into the team will be the first one to complain. After 1 month, probably his energy fades, and then, yeah, this is fine. The important side effect is that when this happens, it gives you complete opposite of what it was built for, which is the complete lack of confidence over your system. If everything is broken, you don't care anymore, which means there is the new red. There is that red where the tribal knowledge is going to be what dictates this is the serious red, slightly different from that red. We've all been there, we've all done that. What's going to happen in these slides is exactly how you can prevent this from happening. But I need to start defining some terminology up front. And you probably guessed from the title of this talk that there is monitoring, there is alerting, and there's a bunch of different buzzwords that are often used, and we need to establish once and for all, what are they? This is not, most of the things that I'm going to have on my slides, they are not my words. I just happen to believe that they are the best definitions possible, so I just point them. Monitoring is something completely different. Monitoring is just collection of signals with the ability to visualize them whenever you need them. They serve many different purposes. They don't serve just for the incident, for the reactive things that we often do. They serve to go look over trends. They serve to go and see past history, behavior. This is just monitoring. These are just data points that you often plot, and you can use them for many different reasons, capacity planning, things like that. This is not alerting. Alerting is a very specific thing. Alerting is when you often want a human to react to a breach of a signal that you know that this is not okay anymore. So just to establish that monitoring and alerting, they are two completely separate things. One needs the other one, usually. What do we use these things for? This is, once again, you can read all of this in the SRE book in case you haven't already, but this is for me one of the great definitions on the what versus why. This is one of the most important things when it comes to monitoring, observability, however we want to call it, all that jazz. What versus why, this is what you can use to define what to monitor. But, well, basically, what to monitor is easy. Monitor all things. Monitor everything that you can. What to alert on, this is a different thing. So what, it's what's broken. This is going to be a symptom. Why, this is where you need all of your multiple monitoring data sources so that you can figure out as quickly as possible what is causing this right now. I tend to suggest there is a third W in here. There is the what, the where, and the why. But this would be an entire talk by its own. Actually, that talk will be tomorrow. Today we're going to focus on what versus why. What usually suggests a symptom. Why usually suggests a possible cause for that problem. As I was saying, the monitoring is basically all of the signals that you need at any given point in time, giving the high-level view of the health of your entire distributed system. This can be the load balancers, the caches, the thread pools, the databases, all of the stateless services, everything that you've been used to collect a signal. This is monitoring, collect everything. This is what you're going to end up using whenever something else told you something is wrong. Another bit of definition, this is a very, very old one. I think this has been going around in many slides from many different authors, probably written in a couple of books, is that alerting per se is also a kind of overloaded definition, and there are many different ways of being alerted. There is some consensus, though, that these are the ones that work better. Starting with the first one, by the way, its classification is dependent on the urgency of the reaction of someone. So when something doesn't need an immediate reaction, something that you just want to keep an eye on, look at the trend, this ends up typically in a dashboard or a report of sorts. These are the kind of things that you will end up having in a weekly report that is sent in an email to the whole team, or a dashboard. I don't like very much dashboards, you will probably realize that. Who has gone through this experience? The new guy joins the team, he needs to be onboarded into the systems, he's given the task to, why don't you come up with a fancy new dashboard as a way for you to understand our set of systems, the services, and you build this new dashboard, and this helps you get onboarded into them. And it does so with the help of the others, and everyone is very, very super proud of that dashboard when it's done. Oh, this is nice, the colors are great, and it gives us the signals that we never had until now. And then this becomes there in the wallboard, the TV, large TV in your team area. And then 1 week goes, everyone stops once a day, looks at it, good. And then another week goes by, it's not changing much. It's getting boring. 1 month goes by, the TV is off. No one even notices the TV is off anymore because you stopped looking at it. And that's one part of the problem of the dashboards. They are not screaming for your attention. They are not useful for that. Other instruments are more useful for that. So the next one is, and this is the one that we don't explore much in my experience, is when you actually have the ability to predict, sometimes with a certain accuracy, that this is going to fail in 3 days and 2 hours. Computers are smart. We can actually do this. We can see that disk space is disappearing at this rate, and keeping the current rate, we're going to run out of disk space in 3 days and 2 hours. Today, we probably just page someone when it reaches 80%. Even if we're going to need the next year to use the remaining 20%. And this is why it makes this mechanism a bit special, because we have that ability, but we don't use it so often. And what I'm trying to suggest is this one can very easily be solved by creating a ticket. A ticket in your ticketing system so that the team every day, for example, is looking at the things that will probably be a lane for operational work on unexpected things like that. And this one is going to be there, and oh, there is something for us to do now, because that lane is things that you need to do now. But you don't have to be paged. You don't need to wake up at 2 a.m. to, this is fine until tomorrow morning or until Monday. So there is this special one. On this one, there is also a strong consensus, and in my opinion, that you should avoid at all costs sending this to an email, a team email of sorts, or a mailing list that says foobar alerts. What's going to end up happening is that everyone in the team will create a special filter, archive them automatically in a special folder that no one will ever look at. That's a certain danger in using email for this. It can work. It depends. It requires a certain level of discipline, just saying that there is a lot of danger of this happening. And the last one, the most important one for this talk, is paging alert. I'm going to just summarize it and call it a page. I also learned that this is not a very common thing to have on-call duties here, particularly in Serbia. So being paged would mean something going beep, 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 or 2 a.m., 3 a.m., waking you up, expecting you to act and solve a problem, because this is hurting customers, or hopefully it is hurting customers. Not always the case. So this is a paging alert. The rest of this talk is going to be exactly about this part, and why I'm so passionate about it is that this hurts people. This is feeding blood to the machines, and I think we can do better. I guess you get the point. When this happens, if I am waking up a human, the least we can do is that there is something serious happening, it needs to be actionable, that person should understand exactly what to do to stop the bleeding. What to alert on is the beginning of this story. I was trying already to give a little bit of an idea, and all of these things are different publications that suggest basically the same. When you want to pick what to alert on, when you make the decision to page people, you should do as much as you can to measure symptoms, customer pain. Whatever your service is for, and I'm assuming that is already useful for those customers, you should try to figure out what is it that they expect from that. And taking the example from this morning, they want to be able to press that orange button, place order, and it needs to succeed. This is what they expect. The rest, they probably, if it's not there, they never knew that it was supposed to be there. What they do know, what they expect is that they press that button, they will be charged the right amount of money, they will get some kind of confirmation feedback that your order is being processed. This is a reasonable expectation. And if you think about this, I'm not talking about services of that complexity of 30 dependencies, for example. I'm just specifically talking about this is what your customer expects from the service. They don't care if the relational database that is supporting the address service, which that front end uses, is having high load. He doesn't care, he doesn't know. His expectation will never change. What he wants, I want to be able to place the order, and I want my delivery time to be within the average that I expect. This is a very interesting definition, because there is nothing here mentioning anything like technicalities, microservices, services, databases, nothing like that. And while saying that, it makes me think that there is another mechanism in our industry that specifically talks about that. I don't know how far all of you may be in the whole service level objectives journey. Some of us started a long time ago, some of us are starting now, and it doesn't really matter. This is just a very quick primer on service level objectives. I probably have to read it because I don't want to mess it up. You should pick SLOs that represent the most critical aspects of the user experience. No, I actually don't need to read it, because that one is actually a bit boring. It will repeat again the thing that you should focus on your customer, pain, and the symptoms. And again, repeating that when you're picking good SLOs, instead of, again, going to the database and defining that the latency of a query should be under 20 milliseconds, this is not so important, probably not a good SLO. A good SLO would be that when your customer places the order, it will be successful 99% of the times, and it's going to be faster than 4.5 seconds. Usually checkout processes with payment handlers, they can be tricky. That's why, sadly, those are the typical SLOs. So, SLOs also mention customer pain, symptoms. What we alert on, customer pain and symptoms. I highlighted a couple of sentences on the previous examples, and when defining what we alert on, there were these parts, which was what we alert on, heart failure-centric and human-centric, something that directly affected a customer, something exploding in front of them. Symptom-based monitoring, different way to say the same. Alert on symptoms. These were all different publications from different authors. Symptoms that are associated with end-user pain. Just repeating the same thing over and over, but many different people saying the same. There is something here. Fortunately, on the service level objectives, there is not much, but it also refers to the most critical aspects of the user experience. It's pointing again to the customer, to his experience, and the critical things for them. What your users care about, what keeps them happy. Which helps me to put these things side by side and conclude we might be saying exactly the same thing. These folks that have been working on monitoring observability, they've been saying these things, what hurts them, symptoms. The folks that came up with service level objectives, they basically said the exact same thing, and I actually think they are saying exactly the same. This was just about what to alert on. But in the previous definitions, there was also something about the number of alerts. When is enough? And what we alert on, one of those authors mentioned, keep alerting simple. This is a good opportunity to bring Eberhard's talk from this morning, where developers, or pretty much everyone, worships complexity. It happens. And we should be striving for simplifying. Things can be simple, and alerting is no different. We tend to do all of those different alerts. If this is something that is getting your interest, you definitely want to be in tomorrow's talk about this, but no spoilers. When you have all of those alerts, most probably you can replace all of them with just a single one that focuses on the customer pain. So keeping things simple, aim to have as few alerts as possible. So this is what is said already, what we alert on in the previous quotes. On the service level objectives, there was another one, which is just have enough coverage, which also suggests not too much, but also focus on the things that matter. So once again, the complexity, thanks Eberhard. So once again, when it comes to the number of things, what to alert on and how many SLOs you should have, it seems there is some consensus once again. All of these different authors have been saying the same. Simplify, keep this under control, things that are easy to reason about, easy to understand. So we know what we alert on, we know what SLOs should be about, we know the number of them. These people have been talking about the same thing. Can we formulate something out of this? And now this is probably my own formulation, that a service level objective is a symptom and a certain threshold, a target. You probably define that this should succeed 99.9% of the times. So it should succeed is actually a simple definition of don't throw 500s. The beauty is that we are not sticking to the 500s. You're just saying should succeed. An alert, on the other hand, and you've done this multiple times, is when you somehow capture a certain signal, doesn't matter what the signal is, and you put an alerting threshold, and when that threshold is breached, you trigger an alert. So let's assume that this condition from the signal is your symptom, and the threshold is again what you put in your alert. So it's also very, very similar, which allows me finally to formulate that you should only page when your SLO is breached or in danger of being breached. This is just to accommodate for saving some error budget. So this is the final statement for what all of these different authors have been saying, and I think by adopting this strategy, we can make our lives and the people doing on-call duty and getting paid much, much nicer. But there is an interesting side effect, and this is why I refer to the SLO journey. Sometimes it's hard. You heard about SLOs, you probably went to a couple of conferences, you've heard this being mentioned, but then you go back to your services and the complexity kicks in. Oh, so many services, and what should my SLOs be? It's hard. Even in our organization, we have plenty of teams that could not come up with a single SLO yet. And I think this is an interesting side effect, because these two problems exist. People are not being able to come up easily with SLOs. They are being burned out like crazy with a lot of alerts. And by solving one, I believe they will end up solving the other one. By reviewing their alerting strategy and coming up with symptom-based alerting, they will end up having good SLOs. Obviously, a certain number of things are going to happen. For example, you're going to probably have an incident that your symptom-based alert didn't catch. This usually suggests that it was not a good symptom-based alert, but if it was, it just means that there is a certain SLO that you did not expect yet, so it may help you do that discovery. The cost is reasonable. You had an incident. You probably still have incidents frequently. One thing is going to help the other one. For example, if you are not getting paged ever, this is probably suggesting you that you are doing much, much better than you thought, and you can promise more to your customers. You can have a more clearer statement in terms of service level objective. You can offer more, and even making them happier and compete. So these things will end up working with each other. One important thing of not being paged frequently, this can be a problem. This will hurt confidence. Being under-paged is a problem by itself, because if you are out of touch with production for too long, you will end up discovering the real problems only when you get paged every 6 months. So when this happens, and hopefully this would be the reality everywhere, this should be compensated with some regular game days exercises. They are fun. You discover a lot of things that are hidden in there in the infrastructure. The platform changes. So if this is the case, this is what should happen. If you are being paged too much, can happen. This is actually revealing. So you thought that you were better than you actually are. In that case, the good strategy is to relax the target, the threshold, even if it is just temporarily, because now this just revealed that things are not great. Focusing on that, fixing them, and then slowly increase them again to a level that is a clear, defined goal from your product people, ideally. When going through this exercise, and it's no longer so important if you are looking for the definition of SLOs, or if you are looking to create alerts, although the next checklist is a good checklist for you to go through when coming up with alerting on symptoms. This checklist is supposed to help you when, is this alert good to keep or to delete? Just go through these items in this checklist, and if it fails any of them, it is most probably a good candidate to throw away. So when creating these rules for alerting, you ask yourself these questions, and if the answer is no, then you already know, good candidate to throw away. The first one, does this rule detect an otherwise undetected condition that is urgent, actionable, and actively or imminently user visible? This is a very good statement that basically describes everything that I said before. Customer pain, symptom-based, actionable is an important part here. Can whoever is getting the page do something about this? Sometimes this is different, but is it possible that I can ignore this alert if I'm getting this alert? Can I ignore it for any different reason? Sometimes there are reasons that this can be ignored. For example, something that I've seen, the queue is empty. Empty queue. Well, it just means that nothing is happening upstream. So it does not necessarily always mean that, oh my God, the queue is broken. It just means that the publisher is not pushing work. But I've seen such alerts. So there are circumstances where this is okay. Are there detectable cases where this is not causing any impact to your users, for example? Another very typical one, blue-green deployment. You have the blue, you have the green. It doesn't really matter which one is getting traffic, but you get the point. And, well, you just deploy your canary. You are doing your smoke tests. Errors come up, and people get paged. Well, it's pointless. That's the whole point of canary deployment. You just deploy there, and you're probably even doing the smoke test yourself internally, there is no customer pain whatsoever. And I'm pretty sure that would be some kind of tagging in those resources that would allow your monitoring system to figure out, oh, this is the non-customer facing traffic, there is no impact whatsoever. I mean, you still want the monitoring data, and this is what the smoke test is supposed to feed from to decide to roll back or advance in the deployment. So there are many different circumstances where, for example, you just drain traffic from an entire region. Probably you had an alert saying that this region is not getting any traffic. Well, you just deliberately drained it. So this would also trigger one such alert. The other one is about the urgency. When I get this, can I take action against it? Is this something really urgent that I need to do as quickly as possible? Or when I get this, maybe tomorrow would be okay, maybe in 1 week would be okay, maybe in 1 month would be okay. If the answer is not immediately, I need to do something now, suggesting that this is a poor alerting rule. Are other people getting paged? This is another interesting one, again, very related to tomorrow's talk, which is when a certain thing happens in the platform, how many folks are getting paged and waking up? Well, depending on the size of your organization and the teams that contribute to a certain symptom, like placing an order, can reach 30 sometimes. But this is also an important thing. This checklist is also in the book. And this is what I'm trying to establish here, is that if you look at your current alerting rules, your set of alerting rules, if you feel that you are going through this experience, if you have that red dashboard, I urge you to, if nothing else, take this checklist, look at each and one of those alerts, even if it's just one per week, go through this checklist. If it doesn't comply with these things, or if it triggers the question that make you understand that this is not okay, my recommendation is strongly to remove it, to delete it, especially, and most importantly, if this is indeed paging someone waking up at any point of the day, including 3, 4, 5 a.m. Before I'm going to finish, I have a couple of examples. Usually examples are good, because all of this theory comes into something concrete, and maybe you will find them familiar. This one is one of my personal favorites. Load average is high. Come on, another show of hands. Who had such an alert? Something like this. Liars, again. I'm pretty sure a lot of you have or had such a thing that measures the CPU load in a fleet of stateless services serving whatever. It doesn't really matter. In truth, it is a good proxy. It is a very good proxy for the thing that actually matters, which is probably is going to get slow. As load increases on the capacity, and especially if you are running with limited capacity, eventually you run out of capacity. And then things get slow. Before I jump into that, another piece of theory. Shouldn't it be great that we could use 100% CPU capacity? Because we are paying for that 100% capacity. So we should be using everything that we are paying for. I know this doesn't exist, it's a rather utopic world, but we should be able to use as much as possible. Most often, what I found, this is my experience, that the alerting threshold is not even set to a level that was probably load tested, where the team realized that from that point on, the service actually becomes slower. They are often arbitrary thresholds, like 72%, 42%, I also seen 42%, and of course, all of that slack space is great, and most probably the service is going to work most of the time, but it's a lot of money being thrown out the window. So, a more interesting alert to replace this one would be, is the service fast enough, for example? Because once again, load being high is a very good proxy for things becoming slower. And while measuring, is the service fast enough, you will not only be catching this one, that the instances have high CPU usage, a bunch of other ones like threat contagion and 1,000 different things that can happen within your service that will end up resulting exactly the same symptom. This is also a very good thing in terms of symptom-based alerting. It will catch many more unknowns that you didn't plan for, that you are still not monitoring today. And that's probably why you, every now and then, may still find yourself in this incident because we didn't think about this. Your reaction, I'm going to create an alert on that new root cause that you just discovered. That's why we end up with that red screen. If, on the other hand, you went with a symptom-based approach, then all of those different things would be caught. Another good example, Cassandra node is down. For those that are not very familiar with Cassandra, Cassandra is an eventually consistent NoSQL database. It has no single point of failure. It uses data replication across nodes. And what this suggests usually that you are never running with a single node owning the data. You will always have at least another replica, or often like 3 replicas. This is the most common use case that I found. So you always have 3 nodes with the same data able to serve reads and writes. Yes, we do have this alert almost everywhere. We were even discussing it this morning, that the alternative was to switch this alert only when 2 nodes are down. But let's not digress. 1 node of that database is down. It can actually be accurate mostly, because if your replication factor is 2, you lost redundancy, you just have 1, and losing that 1 would mean a full outage. But also means that depending on your throughput, which you probably load tested with load balancing across 2 nodes, if you now lose 1, will the other one be able to handle the existing throughput? Maybe it won't. This is going to suggest to the previous one, then the load of that surviving node is going to become high. Oh, let's put an alert on how high the CPU load is on the node. But we already know where this is going to. If I was measuring the impact on the edge of the customer service, is adding items to the cart slow? This is the thing that matters. All of these transitive things that we end up doing, they would be caught by something that is customer-facing and causing them pain. Adding items to the cart became slow. So if you had all of these alerts, you could just get rid of them. Monitor them, though. Remember, monitor is one thing, alerting is a different one. There were a couple of other things, for example, the partitioning strategy on Cassandra. This would be too specific, but again, you may end up realizing that you need something like that, but your mileage may vary. Another interesting one is that the EC2 instance is unhealthy, which isn't bad. This suggests that you may have a health check, not bad. But when you have the health check and you are running on AWS and you have those load balancers and the auto-scaling groups, in case you are like me and you patched your own cables and your own data center a long time ago, this was lovely. Making sure that those blinking lights were making sure that things were working, I get it. But this time is gone, which means today we have all of this automation. We have AWS, GCP, Azure, we have Kubernetes. One thing that these things do for us today is that they automate these basic things. If there is a health check, you just need to worry to provide the health check, because then all of this automation will guarantee that when something is not working as expected, it's going to be taken out of service, replaced by a new, fresh one, and this is why it was built for. So that we as humans, we stop worrying about these things, because it's so trivial to automate that we shouldn't be worried about them. If we shouldn't be worrying about them, we should also not be alerted on them. Again, even if it was the case that, for example, you were running with low redundancy, just 2 nodes serving a certain level of throughput, if by losing one temporarily, this puts the throughput entirely on the surviving node, it may happen that your latency goes off the roof for a short amount of time. That's again the interesting signal to monitor on, because probably as you have a monitoring alerting window of 2 minutes or 3 minutes, this is going to be more than enough for the automation to kick in, replace it, the new one is there, and then there is a small increase of your percentile, but everything is fine and everyone is sleeping. This is pretty much the end. This is the talk. I could not finish this without referring to all of my sources. Plenty of great people, great thinkers, fighting for these things, trying to make the profession sustainable, and in a way that we can continue to worship complexity, but making this more manageable and more human. Again, we shouldn't feed blood to the machines. There were also a couple of publications that where I copied pretty much all of these definitions. If you haven't checked them, please check them out. In my own experience, I validated all of these things myself, either in my current company, previous company. Oh, I have plenty of time. which means I may have 10 minutes for questions if you have them. We also have some microphones here. Before we jump into that, I have like a part 2 of this talk tomorrow. Again, I think it's again in this room in the morning at 11:30. You may have seen it in the program as alert on symptoms, they said. I may have said that. I actually changed the title. I think this is a nicer one. Are we all on the same page? Let's fix that. Please, if you're interested in the topic, do attend tomorrow. And I guess we could skip to questions if you have them. I would be happy to answer them. Do you need a mic?
No. Do you have any war stories you can share?
Oh man, I have so many.
Improving alerting or monitoring somewhere.
A recent one, a very, very recent one. I'm not just bullshitting you about this. We're actually walking the walk. So right now, my team and the rest of the incident commanders team, we have an incident commanders team at the company. We are exactly proving how effective this can be. For example, for a customer to log in our platform, as you would expect, there are a couple of transitive requests. There is the front end for that, which has a pseudo backend front end, JavaScript, man. And then something hits a Scala service, which hits another thing that needs to synchronize against something, and then there is a database of sorts somewhere, okay? It's not that complex, but it's still, hey, it's just logging in. I was about to swear. Obviously, all of these individuals, all of these teams, they have their own localized alerting on their own stuff. Their load balancers look peachy, and all of that looks nice. What happens often is, and this is a concrete example, one of these services returns a 404, which is interpreted and promoted by the next one to a 503, or 5XX, doesn't really matter. From that point on, this one is failing, but it's failing so constantly that they already realized, but this is okay. It is okay, because 404 meant that the downstream data source, the customer storage, said this customer doesn't exist. This was completely being ignored because it was there constantly, and it was being ignored. So we apply this approach of alerting on symptoms, which we today do based on distributed tracing, and the traces were there popping up, and we took ownership over that alert. We are getting paid for the customer pain. And when we got the page, no, we need to figure this out. What's causing this? So we just sat down with them, what's causing this? What we came to realize is that customers were able to successfully log in. Thankfully, because of the flow of things, they were being denied due to this error. So a customer that has been deleted, no longer existed, was successfully logging in. No one was seeing this. This was only caught because we started alerting on the symptom. The other ones took this for granted because for them looking localized that, it's a 404, for us we translate to 503 because we can fulfill the request, this is fine. And if you just look at that part, sounds reasonable, but if you think about the customer and their pain, no, he tried to log in and then he was denied. Why? Because his account was deleted. Oh, so this is one. I would have way more war stories, and I'm gonna be around tomorrow, so I don't want to use all of the time. If anyone else has questions? I hope you do. I'm very passionate about this topic. Well, if you don't, you can find me here, also in the Zalando booth, and I'm going to be around. I would like to finish by thanking the previous speakers, which gave me a lot of food for thought and ideas for me to refer to. This is what I really enjoy about conferences, that you learn from each other, you exchange these things, and have a nice rest of the conference. Thank you very much.